correcting, protecting, guiding, guarding, and governing and taking care of us throughout life. We have woken up because of your abundant mercies and grace. Merciful God, this morning we submit ourselves into your holy hands. May you fill us with wisdom and grant us good health as we undertake our everyday need today. Lord, bless the work of our hands so that all that we do today may be fulfilling to us, helpful to humanity, and may we do it according to your holy will and for the great glory of your name. Amen. So, ayong buntag sa tanan, let me start recording this session.
Recording in progress.
So I hope you're seeing all of my screen. It's presentation of the syllabus where we are right now and what we are supposed to be doing. We are on week 6 of your meeting and week 6 naman, week 5 meeting, week 5. And our topic for today is about writing the introduction in literature, which involves some content analysis and also writing your methodology. So deliverables for today, there is a very short exercise on content analysis. And that's it for today. So it will be submitted probably before Saturday next week on or before Saturday of next week. So for the week after today, it's an independent lab work session. So again, Pomodoro technique would refer to you starting to write the content of your introduction, for example, for the first 30 minutes, spending a 10-minute break, and then you write again. This is, again, researchers say they find this method to be effective because especially if you just keep on delaying, if you're a procrastinator, then you keep on delaying writing your content just because the first sentence that you made did not really fulfill or satisfy what you expected yourself to write. So that's for the Pomodoro technique. And I'll eventually start to share something. Here. So writing the introduction and literature review. So this is a slide from engineering journal emails. So I'm just gonna make use of it since it's simplified. Discusses or tackles the different components of your introduction and literature review. So let's start the survey. So here's one thought that I can leave you for this day. You can read that by yourselves. So it's a thought related to doing a scientific research. So what are the components of a good introduction? Your introduction would actually set the pace. It would actually give your audience an idea of what you are trying to sell. You're trying to sell that you have found this gap, then you need to prove why there is indeed a gap in the literature. And you have to cite publication that would affirm that this gap is really not covered from those publications. And you also have to be convincing in a way, persuade your audience, especially your panel, that your gap is unique. Your gap is something that was looked over or looked over by some of the researchers. And maybe you could also cite the relevance of your problem. Like, is this problem one of the most important topics in the research world today? Or is it a problem that was already during the 1970s, 1980s? So if you're going to look back on those times, then your problem might no longer be relevant. So first, establishing key ideas and findings of research literature or real-world context relevant to your research topic. This is the first component. Second component is you present your research problem, and along with it are citations of what's your reference, why you said there was a problem with this, and citations on publications, again, that would affirm that there was indeed a gap or a problem in this portion of the recent topics that were discussed or studied or researched upon in the last few years. And lastly, you do announce. So you have presented your research problem. Let's just say that you have convinced your audience that there is really a need to do a study on this topic. Then you have to announce how will you solve your problem? How will you specifically address or fix the research problem? And the announcement part would involve different methodologies. So let's go over the first component, establishing your key ideas and findings of the research literature that you have read. Now, for the first component, this would somehow indicate whether or not the literature that you have read is recent or was it just some old study. So again, we wish to avoid citing very old studies which may no longer be relevant to our world today. So what are some examples of recent world problems? If we delve into environmental research topics, it's more on how do we stop using fossil fuels? We know that fossil fuels are non-renewable, and in time, maybe decades from now, we'd run out of supply. So solution to that would be you announce that we need to start using um, fuels, maybe made of water or some other organic chemicals, which we can derive from some byproducts from biomasses, let's say from agricultural wastes. So strategy A would, the strategy here involves citing that your problem is really recent today and that it's relevant to the world today, especially that we are in energy crisis. So that's one good example. So examples, indeed, the search of natural compounds and management methods, alternatives or complements to classical pesticides and fungicides has become an intense and productive research field. Now, try to take a look at the italized words. So first, we have intense and yeah, it's a phrase actually, intense and productive. Yeah. So intense and productive here would imply that this is a study that has been conducted by many researchers, probably around the world. So they are really interested in finding a solution to not using anymore those classical pesticides and fungicides. So they wish to look for other alternative solutions. Maybe they could create organic pesticides or fungicides. Next statement. In recent years, there has been a significant resurgent interest in renewable energy sources. So this phrase, or yeah, as some descriptors like significant resurgent interest as being italized here, and then the word recent as well, would tell us that this is a more recent study. And aside from being a recent study, it's somehow related to the first thought that was given in the example, that it's something that has put great interest. And the word resurgent, maybe this was studied in the past, but not really, not a lot of studies focus on this particular topic. And that today, there is a resurgent interest because we are now experiencing energy crisis. So to address energy crisis, one should use renewable energy sources. So these are some key phrases that you could highlight from the studies that you have read. And this would indicate that once you see these phrases, you would then answer, this is component one, strategy A. So these are ways that you can create your introduction, how you make it compelling to your audience. So I hope that's clear. Still under component one, we have strategy B. Strategy B would indicate claims based on research. So you would have to cite who is the author of this idea or thought, or some common knowledge, which is very frequently used. Example, so one claim, a claim that states that all fossil fuels are finite resources. We all know that's a fact, right? So there is no need for you to cite an author or any article from the website that you may have read something about affirming that fossil fuels are limited resources, because everybody knows it's a limited resource. So Anisha, one good example that there is no need for you again to cite the authors because it's common knowledge. Second example, claim that alleges that nuclear energy is the best sustainable energy source. How do you know that? So this is a fact that is something that we can still argue on. Do you have proofs that it is indeed the most or the best sustainable energy source in nuclear energy? So what type of nuclear energy? Is it nuclear fusion or nuclear fission? We all know for a fact that nuclear fission is still not yet used nowadays. It's under intensive research. So for this second statement here, this is a claim that might struck everyone because questions will arise. So how much will I save if I use nuclear energy rather than the conventional burning of fossil fuels to supply electricity to my grid? And for this kind of statements or arguments, you need to cite what researches were done on this, who were the authors. So maybe you could cite here 3 or 5 authors who said about nuclear energy being the best sustainable energy source. So I hope you get the point that there are some thoughts or claims that need not, and I mean, do not need any citations. And there are some claims, let's say, I would say, how would you describe this claim? Still subject to arguments. You need to cite a source. We now go to component three. Component one and strategy C. For this strategy, you need to define terms and constructs in your research that are not frequently used. So you do not expect that your ordinary audience, every time there is really an intention for you to publish this online in any of the known publication journals, or if you plan to present this to a local conference, national conference, or an international conference, that the terms that you have used in your paper will then be understood by everyone. There are some terms in water resources engineering that ordinary people won't understand or can't understand. And there are also some terms in structural engineering that, layman people will not be able to understand as well. So you have to properly define them. For example, LID. What is LID? In water resources, LID stands for low impact development structures. So you need to properly define what are low impact development structures. These are structures that they serve for different purposes. One is to mitigate flooding. So examples of LIDs would be still arguable, would be the use of rainwater harvesting system. So there is a hypothesis that if I use rainwater harvesting system, let's say for a certain subdivision, I might be able to minimize the accumulation of flood at the lowest point in our subdivision. So that's just one example. So how about for structural engineering? Could you give me some terms which some people would say, what kind of term is that? We don't understand that. Maybe you can type your answer. So nobody's answering. So I would say siguro an example of a technical term would be structurally indeterminate structures, structurally determinate structures. So ordinary people who might be attending a conference or reading your article from any public from an online website might not be able to understand it. So you need to properly define it. So we have one, CHB. Yes. So here's another. CHB is, it stands for concrete hollow blocks. But people will understand that if you properly define it. If you have written the first mention of the word concrete hollow blocks the first time, so you need to spell it one out in your study. So please kindly take note of this. The first time that you make mention of a technical term, you have to really spell it out. And the second time that you cite your technical term in the succeeding paragraphs of your introduction or review of related literature, pwede na mo siya i-abbreviate. Like, for example, so the study aims to use, what were the alternatives? Use limestone, crushed limestone as partial replacement to define aggregates for concrete hollow blocks. Then you put their CHVs in close and open parentheses. And then the next paragraph, I know that you would be mentioning CHVs more often, so you can now start using the abbreviated form. No need to write the whole thing like concrete hollow blocks. So pwede na CHV. So the CHV used from study of, let's say, Pytel and so on. And on the third paragraph, CHVs again. Now let's go to the next strategy. Components rather. So there are, again, establishing key findings, key ideas. There are three strategies: recency, problem. What else? The knowledge base. If the knowledge is common knowledge, or is it a knowledge that would speculate a lot of arguments, a lot of hypotheses, which may not be aligned to some other people's hypothesis? Third one is proper definition of technical terms. Next. So once you have presented the recency of your, problem of your research, then you can establish that you can start presenting rather a research problem. So based on your readings from 25 papers or from 50 papers, none of these papers really focus on the study of this particular gap. And this is where you find affirmations on why there is really a need to conduct research into this particular gap. So you need to present that gap. So there are also several strategies when you are presenting a research problem. Strategy 8, you argue for a real world problem or need. This is very frequently used, I would say. Example, to reduce heavy reliance on herbicides and fungicides, there is a need to move to low input sustainable agriculture as a component of integrated weed and fungi management. So take a close look at the italized words, a need. So this is an indicator that you are using strategy. You are now trying to review that you're significant because there is so much reliance, there's heavy reliance on herbicides and fungicides, and there is really a need to move to this another alternative for how do you get rid of those pests and fungi that would result to poor health in your plants. So next strategy, B. You argue that no research was conducted on your topic. This is also one of the commonly used strategies during the proposal hearings of the previous students. I mean, katong nagunan ninyo. And even in literature, you will commonly find this as well. So they argue na, Miss, whatever my research naguhat ani, like sige mig search, we kept on searching for related topics to our research problem, and we couldn't find anything that would help us answer this question we have for this particular topic. So you would argue that there is no research because the knowledge base is very, very small. Let's try to look at an example. So, however, no information is available about its antifungal activity. So I think it's pretty clear. Highlighted word here is, however, no information. So if you spot this in any of the research publications that you have studied or read, then that researcher is using component 2, strategy B, in presenting a research problem. And the third strategy, I think this is the last strategy under component 2, you argue that scant research was conducted on your topic. When you say scant, the knowledge base is very small. There were few publications about it, and you wish to contribute, you wish to add more knowledge to this small library of literature that you have for this particular topic. And this is also frequently used based on the proposal hearings that were presented to us in the past year. Example, while there have been numerous studies examining the biomechanics of typing for body postures, head postures, arm postures, and wrist postures, there have been only 3 studies. So here's the highlight, 3. So we would say the knowledge base is quite small, or it's scant. This is 3 studies according to Kinselman and Baker et al., Summerich et al., and publications of the same author from 1998 and 1996. So that's your key phrase there, only 3 studies. Now, I also would like to share from my own research. This was also one of the strategies that I used because the knowledge on, the data available for the water demand per household is not really available. The recent one that I got from pids.gov.ph is a very outdated water demand. Water demand, when you say water demand, these are the different amounts of water used for flushing the toilets, for consumption like drinking, washing of hands, cooking food. There are different activities under which water is used. So the most recent data I got was from, I think, somewhere from 1998 or 2004 scholarship. So we have to argue that because of that limited data, then my results would largely depend on the data that I inputted, because of, I would have to reason out that it's not the most current water demand because there hasn't been any study conducted for the most recent water demand in most of the households in the city of Cebu or in the province of Cebu generally. So that's strategy C. Now we're on to finding a fix to your problem. You now have to announce what are the different methods that you can address, you can fix the problem that you have. Now, it's important for you to remember that when you cite solutions for the problems that you wish to fix, it shouldn't be one-sided. When I say one-sided, you may already have a solution in your mind, but try to be open to the other solutions. You cannot present just one solution in your literature without describing what are the other techniques used, what were the other methods used by some other publications that also help them solve the same research problem. So we wish to avoid having a solution in mind, and then because you have a solution in mind, you're now just trying to find a problem to which the solution would fit. That's not how it works. So that problem comes first. You do research on that problem. I mean, you made research about that problem and you found a gap. And based on your readings, there are several methods or ways that you can fix it. Then you present those methods, and from there you eliminate which methods are not possible and which of the methods are, appropriate for the local site, appropriate because there is an abundant supply of this material here in Cebu, and you crush out other alternatives based on just one of the factors I would say is availability of your materials. And there are still lots of factors to consider upon the selection of the most appropriate solution. So component three, we now have to make an announcement. First strategy, you state the aim, purpose, objective of your research, this is very frequently used as well, and or describe theoretical or real world contributions of research. So once you have established the key ideas, it was the first step, that was the first component. So you describe what are the recent researches about your narrow down topic. And on the next parts of your paragraphs under introduction or review of your related literature is explaining why the problem that you found is significant and why there is a need to conduct one. So final few paragraphs or on the final paragraph of your paper, the panel should find this. So they should know how you would fix a problem, and they will know how you fix it if you indicate there the objectives of your study. So this is strategy A. Example, this study will compare the kinematics of the digits during typing on a standard keyboard configuration and ergonomic keyboard configuration to determine if an ergonomic keyboard configuration reduced the digit postures and motions that hypothesized to be risk factors for MSD-UV. So I'm not really sure what is MSD-UV, but here you will see to determine. So this is an indicator that you are now trying to tell the panel or the audience that this is one of your objectives, to determine if an ergonomic keyboard configuration would indeed reduce the digit postures and so on. So next, the present work extends to the use of the last model to asymmetric body vortex flow cases, thus increasing the range of flow problems that can be investigated. And the highlighted word here is extends. So probably the methodology was not done for this particular extension of the work. And that's why the researcher intends to extend the use of the last one and level. So that's component three, strategy A. Is there still another strategy under component three? Second, strategy B. You state research question or hypothesis of your research. And this is also commonly found in the write-ups of students from the previous year. So here's an example. The following two hypotheses were examined. One, participants using the ergonomic configuration would, highlighted word, the italized word is would, demonstrate significantly more neutral joint angles, lower joint angle velocities, and so on. By another highlighted word. Two, participants using the ergonomic configuration would demonstrate greater hand displacements compared to using the standard keyboard. So when you say you compare the joint reactions of the participants with the use of the normal keyboard versus the ergonomic keyboard, so it would somehow give some relief to the usual pains that one experiences in their fingers or in their joints in their hands when typing. So this is also another way of announcing how you solve the problem that you just presented or described. So for content analysis, so kindly read lang. It's quite long. So this is from a publication by Chang and Leong, 2014. The goal of content analysis is to identify what components of the writing of an introduction and related literature did the researcher apply. So the researcher apply for the first component, establish key concepts and ideas. Did he apply strategy A, strategy B? So that's we number that as component one for establishing. Component two is for you're presenting your problem, and component three is trying to announce how you would fix it. So one, two, three to stand for the components, and for the strategies under them, we try to write beside it if it's strategy A, B, C under the first component, strategy A, B, C again for the second component, and strategies A or B for the third component. So I'm going to give you like less than a minute to read this again. So you try to analyze which of the strategies or components did the researcher use. Excuse me. So I think most of you are done reading the set paragraphs. So the answers. So first line. Determination of small strain parameters like shear modulus and damping ratio are frequently carried out with advanced geotechnical tests like resonant column, cyclic simple shear, and cyclic triaxial tests. So the key word here is frequently carried out. And this is component one, strategy B. So in strategy B, if you could recall, it's common knowledge. So there's something that you don't need to cite any answers for. So I'm going to show it's strategy 1B. Next. Both the cyclic simple shear and cyclic triaxial tests have been included in testing standards and has been widely used. So you can highlight widely used in the industry, and it's still component one, strategy B. So if I may, let's try to go back to what is component one, strategy B again. So here, component one, your way of establishing the key ideas and findings is through claims based on research, or it could be common knowledge. So common knowledge, the ones that was cited for the first paragraph, the first line of the paragraph, which says the frequently used testing methods as indicated in cyclic tests. And for the second statement, it's still the same strategy, indicate claims based on research. So it's something that is widely studied. So let's go back. Next statement. Another popular test to determine small strain parameters is the wave. So here, popular tests, keyword neto. So it's still under strategy, component one, strategy B. And still the same, bender, extender elements are able to determine small strain parameters of strain smaller than the resonant column. For this is based on a study. So you have to cite the author, DAS 1993, and component one, strategy B. Techniques author or researcher for writing his introduction is more on strategy component one, strategy B. So next, while most research should focus on the determination of stiffness modulus, especially the shear modulus, material damping ratio is seldom. So this is now presenting your problem, but what is the strategy used? So keyword is seldom. And then I'm going to answer theory, that's strategy C. So let's try to recall what component two strategy C is. There, you present your research problem by arguing that there has been very little research conducted on your topic. So I think that was the last statement. Anyway, this paper explores two methods of determining damping ratio using the Bender element tests. So this is now presenting to the panel, presenting to the audience, or to your colleagues, how would you solve the problem that you just presented? Because there is damping ratio is seldom investigated. You tend to investigate that by determining damping ratio. The methods of determining damping ratio are either using Bender element tests. So that's component three, strategy A. Now, there's an activity here that you can do as a group. You try to identify what components and strategies were used by the researchers, Wijaya and Leong, for this particular paragraphs, as extracted from the introduction of their literature or the related studies that they're referring to for their research. So for this one, it's going to be published in Canvas, so there's no need for you to worry about taking a screenshot. So this is just an exercise. If the different components of the writing of an introduction and related literature related things in. So I guess we have some limited time, so I need to move to the next topic. So this is about writing literature and your related literature. Yeah, writing your introduction and related literature. So do you have questions? There are only 61 of you. Where are the others? So I appreciate everyone who woke up early just to join us today. And if you would agree, this is really one of the important tactics that you will learn when you're writing, when you start to write your paper. For your attendance, kindly fill out that form. So we now go to research methodology. You may start filling out the Google Forms for your attendance. Now, we need to make a clear distinction between what is a research method and what is research methodology. So these are some of the common distinctions that we found about research methods. When you say research methods, they are the specific tools and procedures you use to collect and analyze. If you're into construction materials testing, then these specific tools or procedures, that's like, let's say, how do you get the density, the specific gravity, or what are the different experiments that you need to conduct in order to get properties of your aggregates. Surveys, if there is a need for you to get, pulse of people, then you need to conduct these surveys regarding how they feel about a proposed project. If, it's more on the psychosocial behaviors of people, whether they would be agreeable to have that certain project in their area. Statistical tests. So what are statistical tests? These are actually a way of treating your data. So once you have the test results, or once you have the survey results, how would you eliminate biases or outliers from your study? So you need to read again your lessons from your probability and stats class. For research methodology, it's actually the study of methods. So when you say method, well, it pertains to methods, and the word ology, it means the study of. So this is the study of methods. For research methodology, you need not only write what were the different experiments that you wish to include in your methodology, you also have to argue why you need to put this experiment here. So you must be ready to defend yourselves or defend the method that you have chosen. Why is there a need to do this? So let's say, why are you using QGIS instead of ArcGIS? Well, you would argue that QGIS is free and ArcGIS is something that you need to buy or borrow a license from. And then why are you using, let's say, so kanang mga, let's say, wait, the term. Yeah, it's more on defending why you have chosen this set of experiments, surveys, statistical tests. So this is a philosophy or the general principle which will guide your research. So na siya ma-involve in something like ethical issues that you wish to address. So when you conduct a survey, it is necessary that you tell the University of San Carlos Research Center that you intend to include people in your research. Thus, you create a research questionnaire so that you will not be violating any of the personal rights of these participants that you have in mind. Then USC would like to get a list of those respondents, and they would also like to get a copy of your survey questionnaire duly signed by a letter indicating or telling the reason why there is a need to conduct a survey signed by your advisor and of course the group. Research methodology can be categorized into two. One is being qualitative and the other is quantitative. So I think most of you understands the difference between the two. When you say qualitative, this is something that can be felt by the senses, while quantitative is more in numbers. Qualitative research is associated with the use of words, sounds, images, and objects as the data for research and interpretation of the data can be, quite subjective because it's based on personal senses. Quantitative researchers would say is a more objective type of methodology or data because it doesn't rely on human senses. It is associated with numerical data that are contained in experiments, surveys, or past records. And the data, again, is regarded as objective. But sometimes there is a need for you to combine the two types or the two categories of data that you will get from your methodology or from your research itself. So you have qualitative criteria. So you have to put some numbers as to how you would rate this. So is the structural element still in good shape? We have to rate that from a scale of 1 to 10. And every scale would have a descriptor. For quantitative research, it starts with a theory and you have a hypothesis. For example, you may have, yeah, mag-present na po mga proposals or topics that you present from the other groups. So one group presented that they want to use limestone as a building material in making, I don't know, CHVs maybe. So how do you intend to use the limestone? Do you crush it? How fine should they be crushed? What should be the usual diameters? So what will it replace? Will it replace limestone? Sorry. Will it replace sand? Will it replace coarse aggregates like the gravel? So once you have this sufficient theories about the use of limestone, well, the advantages and disadvantages of using limestone in construction, you should cite that in your literature. You then hypothesize. So you say, based on the readings that you had about the use of crushed limestone as partial replacement to the CAs or the FAs, you hypothesized that there could be an increase in its compressive strength. That's a hypothesis that can be proven wrong or correct. So there's nothing wrong if your hypothesis is proven wrong. So you just have to state that the reasons or the factors why it went otherwise. And once you have a hypothesis, because you said that the use of limestone as a partial substitute to coarse aggregates might increase or might improve the mechanical properties of your building material, excuse me, then you find are the suitable methods of data collection. So with the use of limestone, you need to look for, well, a company that would do the crushing for you. You have to be aware of the costs. And once they are already crushed, what should you do with your materials? The same way that you do to your common construction materials, you try to get the properties like what's the specific gravity of the limestone, crushed limestone, what's the FA, what's the distribution of material base? Is it poorly graded? Is it well distributed? Is it uniformly distributed gradation? Is this type of gradation suitable for mixing? Then after you got all those properties, you will then use it in the ACI design mix. So I hope everyone is familiar with the ACI design mix. That's how you design or proportion your cement, sand, gravel, and water. So at the result of the ACI design mix, it should give you specific quantities as to how much gravel, how much sand, how much cement should be in one mix. So it's either in volume or by weight. For qualitative research. So the same way as presented before. So you already have your literature, you have read about it, you found a gap, so you have your problem. So once you found a gap and you already have solution in mind, then you make a hypothesis. So one example of a study that made use of qualitative data is the amount of carbonation. So this students who proposed last year, so what's carbonation? It's actually the carbon dioxide emitted from your construction materials or construction materials like concrete. Your concrete is said to emit carbon dioxide to the surrounding environment, or all of these carbon dioxide would then eventually go to the atmosphere. So they wish to minimize the amount of carbonation. How did they do that? So they created a makeshift chamber. And this pressurized makeshift chamber, they have a tube connected to it, and they have a tank which supplies carbon dioxide to the inside of the chamber. And they're concrete samples with titanium oxide, I think. Yeah, it's titanium dioxide, the O2 So their materials or their concrete samples had this addition of the titanium dioxide. And it is said, based on the very scant literature that they had, that it might probably help in minimizing carbonation effects. So how did they measure the carbonation sa ilahang samples? So they did this, I forgot the name of the test, but they simply have to drop a liquid. So not say liquid, put in a dropper maybe, and they dropped it to one of the cross sections of their samples, and will change on color. So concrete, when it's dry, it's color grayish, right? And when they put that substance in the cross section of your concrete, they would say you would see changes in the colors. So from light pink to dark pink in color, and so on. Now, each of these colors, they're highly dependent on your eyesight. So if you have pretty bad eyesight, like let's say you have hard time determining or telling the difference between a red and a green, so let's say you're colorblind, then you may not be a good judge for the amount of carbonation for the said concrete sample. So it should be someone with good eyesight. So she or he could properly take note of the colors and what are their equivalent meanings. So that's one. So that they have decided to use that, forgot the name, the method, I would say qualitative type of method to test their theory. Oops. So there's an enumeration here of the key differences between the quantitative and qualitative data. I do not wish to read all of them. It's for you to read them, but maybe we can go over some of the lines here, like quantitative type of data is objective, qualitative, for the qualitative data, the objective is to discover and encapsulate meanings once the researcher understands the data. So let's say multi-shahong example ganiha, like the variations in the color pink. So na I light pink, medium pink, darker pink. So they would mean darker pink, I think there is a significant carbonation. So daghan siyang na-emit na carbon dioxide. And the lighter pink na part sa cross-section sa sample kay wala kayo siya mag-emit o carbon dioxide. So that's the interpretation. For a quantitative objective is to test hypothesis that the researcher generates. Like you already have a hypothesis that if I add rice husk as a partial replacement to my cement as a cementitious material, I think it will improve the mechanical properties like the strength. Because based on the studies that you have read, most of their findings or their results were positive. So something like that. And you wish to test because you found a gap from that study and and in turn you still want to test if what if I add another additive, will it somehow affect the strength? And you have a hypothesis in mind that it may not have that much significant effect. So you wish to test that hypothesis through a compressive strength test using the UTM. For quantitative, concepts are in the form of distinct variables. So you have X. What does X stand for? X may stand for the number of days, and Y may stand for compressive strength. So what is the strength of your sample A after 7 days, 21 days, and 28 days? For qualitative, concepts tend to be in the form of themes, motives, generalizations, and the taxonomies. So I would say, ayam kasabot dire, it's more on grouping of the different assessments that you made, like what when you get like the dark pink, medium pink, and light pink results. So this is how you also categorize the results of your samples. So which of the samples had a larger area for dark pink na test result? Which of the samples, so by counting, you would put there had more areas na naay medium pink na color, and another category for samples that had a very large area containing light pink in color. So it's like you have to aggregate your data, categorize them. So third, measures are systematically created before data collection and standardized. When you say standardized, you have to follow tests like ASTM. We also have a different standard. If you're using the European test standards, na as a Indian standards, I think na as ang Japanese. So they also have their own standards as well. So you have to choose which of those standards. Dili siya pwede i-mix nimo. So for testing the specific gravity, you're using Indian standard. For testing the finest modulus, or I mean, for testing the abrasiveness of your sample, naggamit kag ASTM. So, dili siya pwede i-mix-mix. It should be one standard lang when you are doing your methodology. Qualitative. Measures are more specific and may be specific to the individual setting or researcher. So, in most cases, examples where you collect qualitative data are case studies. So, sa inyuha or sa tuwa in engineering practice, there is more focus on the collection of quantitative data rather than qualitative data. So there were studies that may have involved qualitative data, like the one I had told you earlier, the study on the effects of adding titanium dioxide to your concrete samples to test if really there is a decrease in the carbonation. And from our study and during when I was still in college. So our study was the assessment of the weighing sheds along Fuentes Mania. So I'm on vice grad to si Engineer Gitang Mundo. And the goals of the study was to determine if the structural safety of the watersheds based on some criteria. So I got a criteria. It was from an Italian researcher. So we adopted it, and we, aside from the qualitative criteria, of the assessment made for the waiting sheds, if they are still, safe or not, is structural checking for safety. Are the elements used in the metallic or structural elements used for the waiting sheds appropriate? Like, is the size safe? If I use the size, is it too small or is it substandard in a size? So we have to do the design adequacy analysis rather for the waiting sheds. And there, I'll just say more in English. So kindly read na lang the difference between quantitative and qualitative data. So let's just go to some important Annie. To here, when you are conducting a research, it's very important that you are able to replicate it, especially for quantitative data collection. Like procedures are standard and replication is assumed. So if somebody else would address the recommendations you made, if you're already done with your study, they can easily follow the methodology and get the same results. For qualitative, research procedures are particular and, well, respondent based, I would say. So, what if the respondent is no longer alive? So, you would end up getting a different data or result from that methodology. Analysis proceeds by using statistics. So statistics is your friend when it comes to analysis and treatment of your data. So monitor, I would say, try to review how to determine outliers, how to um, how to determine the variation in your data. If it's like it if it would fall under the bell-shaped distribution, so if it's outside the 95% confidence limits, then that's a time that you would reject particular results. And that analysis for qualitative data proceeds by extracting themes and generalizations from evidence and organizing data to present a coherent, consistent picture. So one example of qualitative data is with the use of digital elevation models, and you wish to extract information from them, like you wish to get what sites are of high risk to a landslide, what locations are of high risk when there is a 100-year storm return period, so which areas are very vulnerable to flooding, and we wish to we wish to minimize the incidences of houses being carried away by very strong river currents. So research methods. Research should be based on a scientific method. And just a warning, I'm not really a warning. Ano to no? For those who intend to use the proportioning na ilang makikita sa book ni Fajardo. So there is this construction materials estimates book by Fajardo. So he indicated there the different ways that you can create Class A, class B, class C mixtures for your concrete. So if you have class AA, it would yield it's a high strength type of concrete. If it's class A, so it would have the strength that is slightly lesser than class AA. If you have a class C mixture, then that's intended for masonry jobs like the the cement mixture you would add into your hollow blocks or for plastering purposes. So let's go back. Scientific method is generally described as consisting of 6 to 8 stages. That's according to Hitchcock and Hughes. First, you have to state the problem. Second, you design the experiment based on that problem. Collect samples and identify variables. Third, observe correlations and identify patterns. So you should have imagined already the output of the study. So how will you present the results? What are the expected results? So you put in your mind, maybe I want to make a graph showing the number of days and versus on the y-axis the strength. So there's a comparison between the development of strength with time. Or maybe you wish to create a chart showing the results of your study that the more recycled aggregates you add, what's the effect on its strength? Did it increase? Did the trend go down, which means it decreased? That's for number 3. 4, form hypothesis to explain regularities. So when you added, let's say, fly ash, it somehow enhanced the strength of your concrete. So that's your hypothesis, and that can be proven only after you have made a test. So if after making the test, indeed it improved the strength of your concrete, then it's one hypothesis that has been proven. So that would help also explain the regularities, like why was there an expected increase in strength? So you have to go back to your literature, cite the authors who conducted the same research, and then you also cite their thoughts on why it actually enhanced, let's say, the concrete strength. Number 5, test explanations and predictions. So how do you test your hypothesis falsifiability? So one way of testing it is we have if you only have 2 samples, I know not 2 samples, but 2 variables, then you can do the t-test or the p-test. And if you have lots of variables in your study, then you could perform ANOVA. Number 6, develop loss or reject the hypothesis. So I think this is just connected to number 5. And once you're done with the t-test, p-test, or the ANOVA, then it helps you decide whether or not to accept the hypothesis you had earlier. Number 7, make generalizations. And number 8, form new theories. So this is now 7 and 8 are part of your conclusion. And let's further categorize your research methods. 1 is considered to be experimental. 2nd is quasi-experimental. And next is survey research. So survey is with a questionnaire solution type. For experimental research, you need to establish the causal effect or relationship. Because of the cause, this is the effect. And the effect must always be connected to the cause. Number 1, when the cause occurs, the effect must follow. This is known as temporal precedence. Number 2, whenever the cause occurs, the effect must also occur, and the stronger the cause is, the stronger will be the effect. This is known as covariation. Number 3, the effect must be due to the cause, and no other causes can explain the effect. So Mona Shah, for those who propose to me mixing different materials, it's really hard to make implications on what really is the cost of mixing the 2 materials on the apparent strength of your sample. So I have advised them to fix the amount of material used for one variable, and they can vary then the amount of the other material to be added to their concrete mixes, because it would really be hard to capture number three if you don't fix one of the variables. So there is this, I'm going to share so that everyone will get what I mean. So they plan on mixing um, crushed chicken bones and maybe some fibers, the hair fibers, I mean the feathers rather, the feathers of the rooster or a chicken. So what's the effect if I add this crushed chicken bones and feathers, which will serve as a fiber, because it will maybe, hypothesis is it could enhance the tensile strength of your sample to your concrete. And it's quite hard to know what really causes a downtrend or an uptrend in the strength if you don't fix one of the materials that you will add. So here's what will happen. You have to fix the amount of crushed chicken bones, and you can vary the amount of feather fibers that you can add. So from there, the conclusions that you will make will solely be based on what's the cost of the strength. So maybe the tensile strength improved because of the increasing amount of the cost. The cost is the amount of feather fibers. Experiments can be conducted using standards or non-standard procedures. For standardized procedures, yes, you can adapt that of the ISO or the ASTM standards. For non-standard procedures, for as long as it's well established in your literature, then you can go for it. You can follow that as well. So here are some more descriptions about making an experimental research in which all of you are going to take or perform. Important considerations in your research when it's experimental time. Number one, dependent and independent variables are present in all experiments. Two, sampling method and sampling bias, they need to be established when conducting tests on selected samples from population. And this is ideal if you have, again, people respondents. Number three, a control experiment is needed. So kindly take note. You have to compare the results of your test with some control sample to establish that the effect is really due to the cost and no other concepts can explain the effect. Number four, it should be something that can be repeated and can be reproduced. Even if you're already done with your study, future researchers want to reproduce, want to do the methodology that you did, and that it must display the same results if you did it again. Number five, accuracy and precision refers to the reliability of the measurement. So how reliable are your results? Are you sure that you are using acceptable results? So if you have tests, you have test results for 3 samples after a 7-day test, and let's say the following test results are 1,900, 1,890, and the other result falls behind 1,000 psi. So should you include the 1,000 psi result when averaging the strength of your concrete after 7 days of curing? The answer, I would say, would largely depend on whether or not you did apply the outliers. Did you determine which of the samples were, which of the results was or were outliers? So you have to be familiar of what an outlier is. Number 6, estimation of uncertainty is required as all measurements involve some error, which is technically known as uncertainty. So that's why the more test samples that you test, the closer you will arrive to the true answer. So, for example, for the concrete specimens, you are only required, most of the time you require our advice is to just prepare 3 samples for a 7-day test, 14-day test, 28-day test, and then I left out 21-day test. Now, is the 3 samples for the 7-day test enough? Dili siya enough. But because we want to minimize expenses, then pera 3 samples. But what's really ideal is if we have 5 samples, you would get a more reliable data. You have 10 samples on the 7-day test for the same mixture. That's even more acceptable than just having 3 samples. So I hope you get what I mean. The more samples you have to be tested, the better will be the results, and the closer they will be to the true answer. So another type of experimental research is the so-called quasi-experimental one. And this refers to non-randomized intervention studies. It's also a term used for quasi-experimental research or non-experimental research, that's according to Edmonds and Kennedy. So in engineering, quasi-experimental research development may include development or design of product or a system where product can be a software, material, equipment, or a process. So in the previous years, there was this one project study group, and they were making use of, they were actually designing. So I think Excel or Visual Basic, they use Visual Basic in the design of any structural element. Maybe it was just um, pertinent to the beam or the column. So once you have inputted there, the dead load, the live load, the dead load, live load, the length of your spans, the height of how high is your column, how many stories the building is, then it would automatically display there the optimized number of rebars for a beam and a column. Not quite sure though if it's master's position or if it's an undergrad study. But the result of that particular study was somehow like a programming program. So pwede siya mahilig sa software but not there yet. So that is if you are engaging yourselves in an experiment that would yield any of these products, material, equipment, process, or software. And quasi-experiment design include pre-test, post-test, time series, and even case studies. So for the survey research, so this is the usual paper and pen, go to the respondents, let them answer a questionnaire, and do some face-to-face interviews. You call them. So, hello, this is blah, blah, blah. I'm here to blah, 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 conduct a research. And what else? You can send them an email, maybe send them a Google Form link, or maybe do the interview through messengers, or lots of ways that you can do survey research. And the success of the survey research depends on sampling, measurement, and the overall survey design. So one of the things you need to check is whether or not the questions are already biased. When I say bias, you would say, example, let me have a political survey. Who would you be voting for in the 2024 presidential elections in the US? So would you be voting for A, Donald Trump, B, Nancy Pelosi, C, Barack Obama? So kato siya ng mga questions. Now, the way you arrange your, the possible candidates is also part of introducing biases to your survey. Because first they muna names a candidate, Casey Donald Trump, then there's a possibility that ganahandaan or your respondent already somehow likes Donald Trump. So mas spark bali kaniya ang pagkagusto. So she or he might choose again Donald Trump. So what if we just rearrange it? So there's a proper design to the questions that you have to ask so that the biases that you introduce to your question will be minimized. And for that, I'm not claiming to be an expert, but you can consult a mathematician. So you can go to the mathematics department. Visualizing the research methodology. Number one, experimental flow diagram, experimental design. So we're almost done the journey. Information flow diagrams. It is important that when you make your methodologies, your panels will always look for this. What's the flow of your experiment? So how will you present that? Number one, experimental flow diagram. It's a diagram that shows those experimental methods in answering the research questions, also known as the procedure flow diagram. And how does it? This is component A. This is method A, and I would get output A. So another component, you added another material maybe. So you perform method B, and eventually the results from your method A and B will be tested in common method C. If it would yield very synonymous output B. Number two, experimental design. It's an input-output diagram that shows how the experimental data is obtained. So here, these are the input variables. So say input for experiment A, and I get the output variables. If you're using staff, what are the values of the that load lengths, the spans of your beams, dimensions of your slabs. So you conduct it on program, let's say stat, and you get output variables. So what are the number of rebars and dimensions of your optimized concrete design, and so on. Number three, also information flow diagram. It's just like an IO diagram that shows how the obtained experimental data is processed. So here's an example. So this is my raw data collected. So X variables, Y variables. And in the data processing, it's part of the input. So you have an equation that defines your, well, what it is that you intend to compute. Maybe you want to compute the reliability of tank when supplying water to a household. So that's Y. And X here would pertain to water demand. Y here would pertain to just how large is the water tank. And the output data would be in percent. So if you're going to use a 1 cubic meter tank as your cistern tank for the collection of rainwater, after, well, maybe depending on the storm return period, then the reliability is only 50%. So it's about 50%. So what does it mean? Is it economical? Is it the most appropriate tank size that you can adopt for your house? So you also have to check that with an assessment optimization tool, whether or not you would adopt it or not. Yeah, I think that's pretty much it. Okay. Do you have questions? So it's almost 900. I know that you have another activity, but if you have questions now regarding your introduction to your, writing your introduction and related literature, and how you can start making your diagrams, your flow diagrams for your experiments, for your methodology, then the first person you need to approach are your advisors, because that's their job. You may set a meeting with them, and if they're really, really busy, so I might be your last option. So I could also help you in the construction of your introduction and your methodology. But I would give most of my time to Quang advices. But anyway, just just tell your representative or just send me an email if you wish to have a schedule for it. Um, what is it today? Perfect in October. No, so next month I might be kind of scheduling some days intended for consultation purposes, general consultation purposes. So just wait for the Google Sheets form, no, sige na siya. The Google Excel na spreadsheet, mag, maghimo ko og another set of schedules where you could see me again for another construction, another consultation. So that's a different time that I would allocate as well for my advices. So sa kung ang mga advice, just send me an email as to when you wish to have the consultation. And you can also do the same to those who have different advisors. Okay, so wala any questions? Share na din ta. So let me stop sharing. Okay, how do I stop recording?
Recording stopped.
Right. So if you have no more questions, I thank you all. Yeah. From Neil, there's a question from Neil. So we have 2 more minutes. Is this consultation still for general purposes? In having the schedule, yes, it's for general purposes. So maybe you have some questions about the lecture we had today and you want to apply it, but you know, there will always be questions arising from it. So yes, it's a general consultation, 30 minutes per group, just like before. I hope I answered your question, Lau. Anybody else? Last minute. So wala na. So thank you everyone for coming for today's session. And you'll no longer be having any more lectures. So ako na siyang gitingog today because I want you to start writing now your introduction and methodology so you will have more time. By next month, dapat na forma na ang inyong introduction and methodology. So you schedule din na siya. First 2 weeks will be introduction. The next 2 weeks will be for methodology. And by November, dapat na may pirma sa inyong advisor that they are now endorsing your papers so that you can now start scheduling for the proposal hearings. Okay, so that's our goal. And that's it for today. So you're now dismissed. Everyone can now leave the Zoom meeting. Bye, everyone.